Hey guys, welcome to another Project Euler episode. This is problem 15, lattice paths. Starting in the top left corner of a 2x2 grid and only being able to move right and down, there are exactly 6 routes to the bottom right corner, as are displayed here. How many such routes are there through a 20x20 grid? This can seem very daunting at first if you do not know where to look. So here is a Wikipedia article on binomial coefficients. And the reason we can use this is because if we break this down, in all of these examples, there are 4 ways to get to the bottom right corner. And 4 is just 2 times one of the sides. So the reason we can use this in combinations is because n choose k. How many how many ways are there to move in 2n possible places? So how many n ways are there to move in 2n possible places? I know that doesn't quite make sense as seeing it, but trust me on this. Oop, you didn't see that answer. So, how would we start to do this? Well, the multiplicative formula gives exactly what we need. We're not going to use factorials or anything. Instead, we're going to use this right here. Or, yeah, more like this one. My bad. This one right there. So, let's get started. We want a final int size, and that's going to be our grid size. And our grid size is 20. And then we need a num solutions. And that's going to equal 1 because it is a multiplicative formula. So you need to multiply it by something. If it's 0, it will always be 0. So what we need next is a loop, more specifically a for loop, to go through each of the sizes from 0 to, well, not 0, from basically 1 to 20. We're going to start at 0 though. There will be 20 loops though, 20 iterations through here. So right here, we need to understand that this is multiplying, so num solutions will times equal something, okay? Our n is going to be 2 times our current grid size, or 2 times our size. So 2 times size. And then what is our I going to be? Our k minus I. Our k minus I is actually just going to be I in this case. Sorry. I'm still sick, guys, if you can't tell. Yes. And then down here, we're just going to divide equal by I plus 1. The reason it's I plus 1 and it's not I plus 1 up here is because, first of all, you cannot divide by 0. Second of all, it needs to divide by the actual size, if that makes any sense. I'm sorry, this one is really hard to explain. I'm trying my best here. Hopefully you understand more by reading what the binomial coefficient is, which is what we're using, and the multiplicative formula. This is actually all we need for implementation. So system.out.printf, the number of solutions is I'm going to try and go through this one more time and explain it to you. This is just our grid size. this is how many solutions we're going to have at the end. This iterates through 20 times, each through the size. This is given by the formula. These two lines are basically what this is, what this formula right here is saying, or this equation. Right here is the minus I divided by I, and this is 2 times the size, or 2 times k. So this gives a output of, that took a long time, 137, 1, 2, 3 billion, 846,528, 820 possible solutions. But is that the correct answer? That looks like the correct answer. I'm just going to say it is. Thank you guys for watching. I'm sorry it was kind of hard to explain this one. It will be easier if you read about the binomial coefficient and are able to relate it to this. I just trust Wikipedia on this one, I'm guessing. But subscribe for more, and